Hi everyone. So in today's lesson, we're going to work on what to do when we're putting more than one transformation on a figure, or we're applying more than one transformation. So that's also known as compositions of transformations. Composition is like when you're putting of functions is when you're putting one function in another function. But there's lots of other ways that word can be used when you're putting things together. You're composing, you're making up something. So your notes for today, they get folded into this really cool book. So right now yours will be flat. I'll show you how to fold this book in class though, but it's going to end up being like a book like this. So that's why on your page some of the things are written upside down and stuff, because it's going to get folded into this little book. Okay, so let's start looking at some of our theorems that we have. So when we compose two or more transformations, it's called a composition, just like what we talked about. Okay, and that lets us do a lot of other things with our shape, or lets us figure out a lot of things. So the first thing we're going to talk about is that if we have a translation or a rotation, basically that can be broken up into two reflections. So any translation or rotation that we have, we can get the same picture or image if we did two reflections. Okay, so we're going to talk about these kind of individually. So if we're flipping over or reflecting over two lines that happen to be parallel, then that is the same as a translation. So that's back what this was talking about. Translation or rotation can be two reflections. So to get the translation, it's like reflecting over parallel lines, and that's how you would make your translation. So first we flipped over L, and then we took that picture and flipped it over M. So that would be our image. This was the original. So flipping over two lines is the same thing as doing a slide. Let's turn our paper and look at the next one. So if we reflect or flip over two lines that intersect, then that would be a rotation. So first I flipped over A, and then I flipped over B, but that would have been the same thing if I just took it and turned it, and it would have landed there. So two flips over intersecting lines is the same as a rotation. Okay, so this fundamental theorem of isometries, it's saying basically that if you have any kind of isometry, which remember is a transformation that makes congruent figures, so basically anything but a dilation, then we can do this by reflecting at most 3 times. So we can get any transformation except a dilation by reflecting at most 3 times. So it only takes 3 reflections to get any kind of isometry or congruent transformation. And then another type of isometry or transformation that we're going to look at is called a glide reflection. Basically, this just is if we translate and reflect. So for here, we flipped over, we reflected, and then we slid. So that's a glide reflection, because you're doing a translation and reflecting. And last, here is our list of isometries. So there are 4, and that is like what we were just saying: reflection, translation, rotation, and the glide reflection. So those transformations all create congruent images. Okay, so let's take a look at our examples. So we're going to start with our first graph up at the top. So it says to complete the glide reflection, if our rule is x, y minus 5, and we're reflecting over y equals 0. Okay, so we have a line of reflection and a translation because we're doing a glide reflection, so that means 2 things are happening. So we're reflecting over this line x equals 0, and we're going to flip or translate it down 5 units. So when you're doing these, sometimes like the one on the bottom, you have to do each transformation like as its own. But for this one, you can do both things kind of at the same time, because if I'm reflecting over this line, I would just pop E right here, but now I have to move it down as well. So I reflected, and now I'm gonna glide it down 5. So this would be where E prime is. Okay, so I'm reflecting, so I'm moving over 2 for X, and then I'm moving down 5. So that is X prime. So we're at 5, and then I move down 5. So T prime. So this is our glide reflection. We reflected and we slid it down 5. So our ordered pairs would be T prime is at 5, -3. E prime is at 1, -2. And X prime is at 2, -4. So if doing both things at the same time is hard, then do one at a time. Reflect it, draw the image there, and then slide it and draw the final image. This is what your answer should be with this final transformation. But if you need to do it in 2 steps, then that's what you should do. Okay, so I want you to try the next one by yourself, and then I'll show you what the answer is. So the line that we're reflecting over is y = -2, which is this line here. So we're reflecting over y = -2, and we're doing a translation. So go ahead and try that, and then we'll do that last one together. Okay, so here's what we got. So I reflected, and then I slid it over 1. So that would be where our final answer is. I had to add a point to make E fit. There wasn't enough points on our graph. Okay, so let's do the last glide rotation or glide reflection, and then we'll talk about all those spins that are on the bottom right side. So for this one, we're reflecting across the line y = x, and we're doing a big translation. So remember, reflecting off the line y = x, that's that slanted line. Kind of freehanding it, not so well. So this is our reflection line, y = x. So, I mean, there's a couple different ways you can approach this. You can do the translation first and then the reflection, or you can do the reflection and then the translation. But for this one, it's a lot harder to do it in 1 step. So I'm going to do it in 2 steps. So first, I'm going to reflect, and then I'll slide it back where it goes. Okay? Well, actually, I think I'm going to the glide reflection. So I'm going to slide it first and then reflect it. So if we have x + 4, y - 5, that means I'm moving to the right 4 and down 5. So I'm going to count on each point. To the right 4 and down 3, 4, 5, right here. E prime. Well, not E prime. This is just E like half prime because we're only doing half the things we want. Half prime's not a thing though. Don't use that. 3, 4, 5. I like to make up math words. So we're moving over 4 and down 2, 4, 5. So there's T. Okay, so here's not prime. What am I doing? I mean, you could call it prime and then call the last one double prime if you wanted. But really it's just one thing. Like it's one translation, even though we're doing kind of 2 separate ones. So I don't like to do that. Okay, so now we need to take that and reflect it over that green line, and that'll be our final answer. But remember, to reflect over our y = x line, we have to flip the ordered pairs of our points. So I'm going to list them here so I can see what we have. So that's -1, -3. E is at 3, -2, and x is at 2, -4. Okay, so now to get those new points, I'm just going to flip, and that'll be our primes. So T is really going to be at -3, -1. So here's our final T point right there. E is at -2, 3. There's our final E point. And X is at 2, -4, or JK, -4, 2. -4, 2. So there is our final glide reflection. So we slid it and then reflected it, and we end up laying in kind of back on top of each other. Okay, good. So let's take a look at our spins. So for this, it's saying that each one's an isometry, meaning it's going to be the same size. We want to tell if the orientation is the same or opposite of the original, which this is our original. And then we want to say what kind of isometry is it. So is it a translation, a reflection, rotation, or a combination of those things? Since they're not on coordinate planes, some of it, the translations will be hard because basically any of them can be a translation. So let's look at what we got. So this first one. So is it turned the same way as this original, or is it flipped? Good, it's going to be opposite orientation since it's not facing the same way. And the only way we could get that is by doing a reflection. So this next one over here, is that the same orientation as this? Is it faced the same way, or is it opposite? Good, it's the same. So for this one, our transformations could have been a translation. We could have slid it, or we could have rotated it 100 or 360 degrees, so spun it all the way around. That's the only way to get it to look the way it is. So what about this one? Good, that one's the same too. And we got it by doing a rotation. And the last one? Good, it's opposite orientation. And we got it by doing a reflection and a rotation. We had to do both. Very good. So that is all for our notes. I will show you how they're going to end up going in your notebook in class. Thank you.